Hi guys, in my previous concept I discussed about projectile motion. So in the projectile motion we come to know that an object is moving in projectile motion, so its velocity is resolved into corresponding components, the horizontal component and its vertical component. How the horizontal component and vertical component affects the projectile motion. So throughout the projectile motion, so the horizontal component of velocity remains constant, but the vertical component of velocity is changes. It is due to because of acceleration due to gravity. And at the top of the projectile motion, at the top of the trajectory, the vertical component of velocity equal to 0. Now we derive the equation of trajectory and time of flight and the horizontal range. So this trajectory is known as parabola. So the expression for parabola, it is a quadratic equation. So y equal to some ax minus bx square. So here a and b are two constants. So that what we derived the equation of trajectory is a parabola. And after that we derived the time of flight. So time of flight equal to 2u sine theta upon g. The time taken by the projectile from the launching to when it lands in the horizontal. Suppose if I have control at here initial speed, suppose if I take initial speed 15 meter per second, so here the initial speed equal to 15 meter per second. Since time of flight is directly proportional to initial velocity, when we increase the initial velocity, then the time of flight is also increases. If you launch a projectile and the time taken throughout its travel is known as time of flight. Now if I can increase to maximum 25, here I can get it. Now it takes a long distance because its initial velocity is more and time of flight is also more because time of flight is directly proportional to u, initial velocity. And here you can notice one more term, so that is the time of flight is directly proportional to sine theta. So time of flight is directly proportional to sine theta. Okay, the angle of projection, sine of angle. Now if you can discuss the another concept, that is horizontal range. Suppose what is the horizontal range? We can get horizontal range r equal to u square sine 2 theta upon g. The horizontal range r is directly proportional to u square, initial velocity, and is also depends upon the factor of sine 2 theta. Suppose if I take different angles, suppose I am launching the projectile with an angle of 15 meter per second with an angle of 30 degrees. Suppose if this is the launch, the distance covered by the projectile is exactly the 19.4 meter. So this is for an angle of u equal to 15 meter per second initial velocity and angle theta equal to 30 degree. Now if I change angle to 30 to 45 degree, now if you launch projectile with the same initial velocity, now I did not change the initial velocity, but by changing the angle, By changing the angle, I wish I would launch one more time. By changing the angle to know what is the horizontal range. So the horizontal range of the projectile is, if theta equal to 45, so this is theta equal to 45 degree. So I got it at here roughly 23.2 meter. Let's do some simple mathematics, how this theta affects the horizontal range. For horizontal range, r equal to u square sine 2 theta upon g. Suppose if theta equal to 30 degree and u initial velocity equal to 10 meter per second and acceleration to gravity g equal to approximately it's 9.8. For calculation purpose, I take that theta equal to acceleration to gravity g equal to 10 meter per second square. Now try to find the r value at here. So r equal to u value 10 square and sine 2 times 30 upon 10. So 10 in 10 square, you can get r equal to 10 on numerator, sine 2 times 30, here we can get sine 60. So r equal to 10 times sine 60. Sine 60 value here is equal to root 3 upon 2. So 10 in 5 times, so r equal to 5 root 3. If I do that in calculator, let me get the value. So the value at here r equal to 5 times root 3 value 1.731 approximately. So r here I got it 8.66. So here range, it is in terms of meter, horizontal range. So what happens if I change theta? So instead of theta for the same, now if I change theta equal to 15 degree and u initial velocity equal to only 10 meter per second and acceleration to gravity is also 10 meter per second square. So let us calculate the range r equal to, so here I can get 10 square and sine 2 times 15 degree upon 10. So 10 in 10 square 1 times, so range r equal to 10 times sine 30 to 2 times 15 sine 30, r equal to 10 of sine 30 value 1 upon 2. So we got it at here, range r equal to 5 meters. So here I do not change the initial velocity, but what did I change? I just changed the angle only. If you change the angle, so you can notice how much difference here, approximately 3.66 meters difference. So what happens if I take an angle greater than the 30 degree? Suppose if I take an angle here, theta equal to, this time I'll take 45 degree and initial velocity equal to same 10 meter per second and g equal to 10 meter per second square, acceleration due to gravity. So try to get the value of horizontal range. So r equal to u 10 square sine 2 times 45 degree upon, what's the value? Acceleration gravity, here it is 10. So 10 in 10 1 times, r equal to 10 of sine 90. So range r equal to 10 times sine 90 value equal to 1. So range equal to 10 meters. So do you notice the considerable change in the values in the three cases? In the three cases, range r equal to, this is for angle of 60 degree and this is for angle of 15 degree. This is for angle of 45 degree. So if the angle of projection equal to 45 degree, then the projectile reaches to maximum range. Again repeating, if the angle of projection equal to 45 degree, then the projectile reaches to maximum range. Let us observe that. Suppose if I project this with the angle of what I have calculated here. So I cannot take 15 degree because of the height problem at here. So the maximum here I can get only 15 degrees, sorry 25 degree. So let me take the other two angles. One is sine 30 degree. Suppose if it is 30 degree. So if I launch projectile, so the maximum range here I can guess, yeah, roughly 14.5. Anyway, I will change to that is 10. So let me check my calculations. So according to my calculation, it is coming around 8 point something. So if you launch a projectile with an initial velocity of 10 meter per second, so it is coming around 8.33, roughly 9 meters. So that is the projectile for angle theta equal to u equal to 10 meter per second initial velocity and theta equal to 30 degree. For the second case, u equal to 10 meter per second and theta equal to 45 degree. Now here I can change the angle for 45 degree. Now if I launch projectile again, so it is coming around 10 meters. Now that is the second case. Now what happens if I increase u equal to 10 meter per second and theta angle of projection equal to 90 degree. So what do you think? That is u square sine 2 times 90 degree upon g. So sin 90, its value goes to 180. Now if I can increase that as maximum perpendicular, if you can launch projectile, now that will be turns back. Now it is turning back. So because sine 90 degree, here if I do calculation at here, I have take the 10 square, sine 290s are 180 degree upon 10. So 10 in 10 square 10 times, sine 180 value here minus 1. So minus 1 of 10 is equal to minus 10. So here minus tells about the change in direction. So here you can notice how the projectile is changing its direction. It is going up and again it is falling into the same cannon if theta equal to 90 degrees. So the projectile reaches to maximum range at what angle? That's theta equal to 45 degree. So that is the ideal angle for projectile to reach maximum range. This is a very important point for maximum range. This maximum range, the range of projectile can be increased with the angle, not only with the help of initial velocity, but with the help of angle also we can increase. And apart of that, I would like to discuss one more point, that's about maximum height. Suppose the maximum height we got it h max equal to, that is u square sine square theta upon g, 2g. If you can notice, the height maximum is directly proportional to u square, not only that, sine square theta. So if you can change different angles, Suppose this is the angle of 35 degree. So the maximum height, so I will draw a line at here. Yeah, this is the maximum height, so the H max. And if you can change the angle again for 45 degree. Now here notice the maximum height means the vertical distance of the projectile. The range is here, the range and the maximum height. Now suppose if I increase further, if they change the angle, the vertical height is also increases. Not here you concentrate on the horizontal range, here I am talking about vertical range. So when it can be maximum? So it can be maximum for if we can launch a projectile, it is reaching maximum at here if it is angle goes to 90 degree. So this is the green point we are calling maximum height. So you notice the considerable changes in the maximum height. So the height maximum is also depends upon theta. Not on that one, range is also depends upon theta. Now here I need to discuss one more point, so which is important to me. So that point is, if you see projectile motion range expression, so the range we got it at here, the range R equal to U square sine 2 theta upon G. So here theta value we measured with respect to x-axis. So here theta equal to, right now you are seeing that theta value equal to 40 degree. Sorry, 40 degree, yeah. Now what happens if I measure angle other side, means with respect to y-axis. Now if I measure this is the with respect to y-axis. Now this angle, if I write this in terms of theta, if this angle is equal to theta, the other side the angle how much will write? So this is equal to 90 minus theta. Common sense, because the x and y axis, the angle between the x and y axis equal to 90 degree. So in this case, if I take other angle, so this angle we are known as complementary angle. If you take complementary angle, will there any change? Suppose this is the same diagrammatic explanation. If this is a projectile velocity, this is making an angle theta with the horizontal x-axis. So this is corresponding y-axis. We got it range R equal to U square sine 2 theta upon G. So theta, what we measure, that is with respect to x-axis. Suppose if I take an angle other than that, it means I would like to take angle, this angle, another angle which is also known as complementary angle. So if this angle is theta, this angle goes to 90 degree minus theta. It means if I am measuring the projectile motion from this side, now is there any change in the range? It means I am guessing if theta is equal like this, so the projectile went up to like this. Am I correct? Yeah, this is the horizontal range. Suppose if you measure like this, will the projectile will be go in this direction? Will it move like that? Since I am measuring angle according to this side. So that things do not take place. Why? Because range R equal to U square sine 2 of, now instead of theta, now I will substitute sine 90 minus theta. Okay, now R equal to U square sine, so if I multiply 2 times sine 90, that equal to 180 degree minus 2 theta. So upon G will be carries upon G. So R equal to U square, so this we can write that sine, here we can use one of the trigonometric formula, sine 180 minus theta. So we are having one of the trig relation, sine of 180 degree minus theta, this value here itself becomes sine theta. So here I'm having the same kind of like that, sine of 180 degrees minus 2 theta. So here nothing going to change, I will get back the same expression, sine 2 theta upon g. So in the formula, what is theta at here? So here we are having the same here, 2 theta. That's only the change. So even if you measure the angle with respect to x-axis or with respect to y-axis, the horizontal range is not going to change. It means, so this is the horizontal range not taking place. Always the projectile will move along in this direction only. It's the horizontal range. So if you can launch with the complementary angles, the two complementary angles of a projection for the same horizontal range. Now they both are having same horizontal range. The angles are, what are the two complementary angles? One is theta, another angle is 90 degree minus theta. For the horizontal range, these two angles are equal for the horizontal range. Now we need to derive for the projectile motion, what is the velocity of the projectile at any instant. Suppose here you need to find a point P at here. I want to know what is the velocity of the projectile at this point. So to find the velocity, we need the velocity horizontal component, that equal to u cos theta, and velocity vertical component, this equal to u sin theta minus gt. So these are the two corresponding horizontal component of velocity and vertical component of velocity. And to get the resultant velocity v equal to under root of vx square plus vy square for the magnitude. So this is the calculations we need to do. So I can get the resultant velocity v equal to square root of u cos theta whole square plus u sin theta minus gt whole square. Now let's finish this calculation. The magnitude of the velocity u equal to square root of u square cos square theta plus u square sin square theta plus g square t square minus 2gt u sin theta. So expand this in terms of a minus b whole square formula. Now these two terms are sin square theta plus cos square theta, and u square gets common. So this value gives us equal to 1. So the magnitude of velocity v equal to square root of u square plus g square t square minus 2gt u cos theta. Yeah. What about the direction? For the direction, we need to calculate tan beta. So here the beta equal to the angle of the velocity vector with the x-axis, x component. So this is we call beta. Now that angle at that location, because since it's the parabola, the angle gets changes. Now we need to divide velocity y component upon velocity x component. So velocity y component we got it u sin theta minus gt upon x component u cos theta. So the angle at any location is depends upon the initial angle and initial velocity. U gets cancelled here, and g acceleration due to gravity, and t goes to time of flight. And what about the velocity of the projectile at the end? It means, so I launch a projectile with a initial velocity u from at here, what would be the projectile velocity by the end? Suppose if you launch a projectile with initial velocity 10 meter per second, what is the final velocity at here? What is its final velocity at here? Since we know that velocity expression, velocity of the projectile expression, so this expression we already know that. So in this one, u is initial velocity, g is acceleration due to gravity, and t is the time of flight. And if I substitute time of flight, so if I can take magnitude of velocity v equal to square root of u square plus g square t square minus 2gt u cos theta. So this is the velocity expression, velocity of the projectile at any instant. At the end also the same expression we get it, but at the end we got the time of flight. Time of flight at the end 2u sin theta upon g. So this is the total time taken by the projectile during to complete its projectile motion. Now if we can substitute that value at here and do the simplification, so let us see how it gets end. V equal to the final velocity at end. I will write that suffix at end position. U square plus g square, in the place of t I need to put this value, that is 2u sin theta upon g whole square minus 2u sin theta upon g times u cos theta. So I am leaving this rest of the calculation to you. You finish that calculations. So but the end result I will write that. The end result is very important. The velocity at the end of the projectile equal to initial velocity. It means at what velocity we launch. At what velocity we launch the projectile, the same velocity will be at here. The final velocity v here equal to same 10 meter per second. Suppose if this is a case of a dropping a bomb or missile. So you are launching a missile with the same projectile. So if you can launch missile with an angle of 45 degree to reach maximum range, yeah, because that theta is equal to the 45 degrees with that angle, the projectile will reach to maximum range. Now if the projectile having very good initial velocity, that may be the initial velocity equal to 500 meter per second. If we neglect air resistance, but originally the air resistance plays very important role, for moment I am neglecting the air resistance, the same velocity will also be there by the end. If we neglect air resistance particularly, then the missile impact is more. If the velocity 500 meter per second means it's a very good velocity. And what about the projectile direction? So by the end, if I take the projectile direction, if this is projectile motion and here it is going positive x and y plane, when it comes to here, so it goes to negative side, so it is going in this direction. Here the angle here theta goes to, if we can measure the angle at there, at here, yeah, this angle is exactly opposite to that. Means opposite in sign. If that is a 45, this angle goes to minus 45. So that how it takes place. How do we measure angle? We need to measure tan beta. To measure angle of direction, so we need to take y component velocity upon x component. So velocity y component we got it at here, u sin theta minus gt upon x component u cos theta. So u sine theta minus g, t is nothing but time of flight. Here time of flight equal to 2u sine theta upon g upon u cos theta. Now if you can do simplification here, I think these two terms gets cancelled, gg gets cancelled, and 1 u also gets cancelled if you can take the u common out. So I will do that after rewriting here tan beta. So tan beta equal to, take the u out, it becomes sine theta minus 2 sine theta upon u cos theta. Now you can cut u, numerator and denominator, and if you can subtract sin theta minus 2 sin theta, there you can get that tan beta equal to minus sin theta upon cos theta. Sin by cos you can get minus tan theta. So on both sides tan is a function, you can cut the tan. Now what is the angle beta equal to minus theta? So that's what I said. Suppose if this is the projectile launching at an angle of theta, so this is angle theta, it is launching. At the end the angle becomes is minus theta, means the same angle comes but it's in the opposite direction. The angle at the end is the exact opposite the direction of the angle of projection. So these are the some of the important concepts to calculate and to know under the projectile motion. So try to read textbook carefully and try to get it what exactly how the velocity components separates and how the vertical component of velocity changes due to acceleration due to gravity that causes, and we will do some problems to get the much more knowledge.